Here in this example, we are given the directions asking us to write the equation relative to this graph in both factored and standard form. So here we have a sketched graph of a polynomial function. We are indicating 1, 2, 3x intercepts. There is an additional point that was indicated on the quiz, and you didn't need to necessarily acknowledge it in order to get the question correct. However, that was like my secret built-in extra credit question. So if you did acknowledge it, which I'll show you how to do that, if you did acknowledge it and check your equation or adjust your equation to ensure that your graph was correct or your equation was actually super precise for that point, you'll get extra credit. Okay, but if you didn't do it, but you did everything else completely as we've been doing in class, you could still get full credit correct for your question. So when you write the equation of a polynomial function, we begin with which of the two forms. So we need to start with one and work our way toward another one. And then we're going to talk about how do we start with that form or that form. So which of the two? Any one of you 17 human beings could type anything. You don't have to even do full sentences. You could just do straight up caveman speak as long as you're throwing things out there. And like I said, if somebody already answered it, you still follow along and you could still answer it. No harm in that. But yes, we start with factored form. So how is it that we should start with factored form? Why is that the easier way to start? So I'm going to write y equals, and I'm going to have all these factors. What do our factors directly relate to on the graph? How are our factors helpful for graphing? What part of the graph should we look at? I'm just stalling and asking questions until somebody tells me something. Okay, x-intercepts, perfect. We also call our x-intercepts by another nickname. The nickname of x-intercepts is called zeros, so that works fine as well. So they give us our x-intercepts. So if x equals -2 identifies for us a 0 or an x-intercept, how do we change that backward into the factor? So x equals -2. I'm addressing that spot right over there. I'll stall a little bit more until people tell me some suggestions or what I should do in the...
+2.
Good, I'm hearing that. Nice, x plus 2. Because x plus 2, if that was inside of your parentheses, inside of your factor, what do you do with that when you're solving? To find your zeros, you said it. Yes, thank you, Spencer. You said it equal to 0. So if I added the 2 back over, like Sophia, I think it was, just told us, then we get the x plus 2. When it's 0, well, we just leave it alone. And this one, I asked you guys to consider this to be something 0.5, right? So if it's right after the 1, well, x equals 1.5. What is 1.5? Let's ask this question this way. Anytime you have a number that's 0.5, if the decimal is only 0.5 after it, it's half of something. In fact, it's half of an odd number, okay? Surprisingly, a lot of people don't know that in high school, okay? So 1.5 is half of an odd number. If it was half of an even number, it would be a perfectly solid integer, right? What is 1.5 half of is my first question. And then when you want to find half of something, what do you do to that number, say, in a calculator, if it was like an annoying number? How do you find half of a number? What is the step operation that you do to get half of a number? So people are saying that 1.5 is half of 3. But what would you do if I'm like 3,700, blah, blah, blah? Good. Kate says we divide it by 2. 3 divided by 2. But division is also what other mathematical thing? What other math representation do we use when we're doing division? Starts with an x, xf, and ends with fraction. A fraction. Good. No one. So 3 over 2 is the same as 3 divided by 2. Now, let's go to our factored form a little bit. One thing, I'm going to spread stuff out so I could always add stuff in still. And we'll build from here. X plus 2. Just x. Or if you want to put x minus 0, you put x minus 0. Now, if it's 3 over 2, some people, right, x equals 3 over 2, kind of did what we did over there, and they subtracted 3 over 2, and they got x minus 3 over 2 is 0. But there was a better way to write this, that if you think a little bit about when you got answers like 3 over 2, what did that look like in your factor most of the time? We never had fractions in our problems before, but sometimes we do get fractions as answers. So how can I tweak this a little bit to make my life easier? If nobody answers, I'll just keep doing it with the fraction, but...
Can't you flip it and get rid of the negative?
Flip it and get rid of the negative? Like flip this over and get rid of this negative?
Yeah, I don't know.
I want you to think back to, if any of you watched and copied from example, I think it was example 1 on the quiz, where we got, I think, negative 5 over 2 as an answer. Negative 5 over 2 is an answer from one of the factors. In your parentheses, you didn't have x plus 5 over 2. What's another way we get rid of a divided by 2? Like if I want to get rid of this fraction, what could I do to everything in this equation? How about that question? If I want to get rid of fractions in this equation, I could take this and multiply every single term by the same number. But, okay, good. I see a couple. Eliana, yep. So we're going to multiply everything by 2. Gibson, pretty late. Follow along. Multiply everything by 2. So if I do that, don't miss anything and don't overcomplicate it. 2 times x will just be 2x. What's 2 times, now think about this logically. What's 2 times 3 divided by 2? What's 2 times 3 divided by 2? Good. It's just 3, so minus 3. And then what's 0 times 2? Right. This should look a little familiar as something that we've seen inside our factors that led to us adding 3, dividing by 2, and getting a fraction as our answer. So you do have the option. You want to put this inside of your parenthesis and you want to deal with that fraction? Sure. You want to put x minus 1.5 and you want to deal with the decimal in your problem? Sure. But why not do something a little bit nicer? So I'll put that here, 2x minus 3. So I start my factored form. I got a bit to go though. What else do we need to address? There's like 2 main things that we need to address before my factored form can be considered finished. What 2 other things? You can name one of the 2 things that I should address to make sure this, because if I graph this, it's not this, I promise. So what 2 other things do we need to look at our picture, right? Analyze, come up to conclusions. One thing Liam is addressing is the exponents. There's a special word for those exponents that go on the outside of our factor. Good, okay, multiplicity. So you're both correct. Good, everyone else, yes. Now, how do I figure out the multiplicity? X plus 2 is the factor corresponding to this spot right here. The multiplicity determines how your graph behaves at that 0. Based on what's drawn in the picture, what that behavior is, we look at one of 3 things. We say it either cuts through the x-axis very straight as a linear behavior. We said it might touch the x-axis and turn around, go back up. That will look like a little baby parabola in the curve, and that's quadratic behavior. And we say that that is what it more or less looks like if the power is one number or a whole set of numbers. And then this one, Oh, we addressed 2. 1, 2. And the third behavior we might have is sort of like if the first 2 had a baby and they're like curved but cuts through and then curves the other way. So it's kind of a mixture of both. So I see the word cubic from Emma, and that is the type of behavior we are looking at right there. That's a cubic behavior, right? It looks like a parabola that broke its arm and it fell down, okay? So that means I go right over here and put a 3 on it. That 3 also means, please, please, this is me begging, it means you do x plus 2, x plus 2, x plus 2. You do not just cube each thing. You go to math jail if you do that, math prison. All right, here, x minus 0 or x if you prefer. So in my next line, I'm just going to get the next line ready. I might put that x in front. I might have the x plus 2 to the third here and that 2x minus 3 here. It's a little bit more nice for me to look at. But the x, which is corresponding to this spot, is what kind of behavior, what is the multiplicity. Remember, I want all of you to participate beginning, middle, end of the class, and this way you get marked present, right? So quadratic, but what degree, or I'm sorry, what multiplicity does that correlate with or correspond to? Good. So that's a 2. So I'm going to put it in both places, so I have both. And then what kind of behavior are we looking at in this third one, and what multiplicity is that? So what's the word and what's the exponent? Good. So that's linear, and I don't even need to write the 1, so I'll leave it in this line, but I'll get rid of it here. Now we're almost there. If you made it up to this, you're almost perfect, but there's one more thing we need to address before we can really focus on expanding this. And what is that other thing?
Miss Thomas, can you move it to the right a little bit? It's cutting off.
Well, I moved my notebook, not the camera, so I think you mean left. Right? Like,
yeah.
Am I doing the right thing? Okay. Mm-hmm. Yeah, because I feel like everyone always says the opposite direction, because I think, like, you guys think I moved the camera, but my camera's, like, kind of locked in. What else you could do, if you can make, I don't know what kind of device you guys are on, if you make your screen wider, I think or like pull your window a certain way, it actually shows a little bit more of the window. But I think you should be able to see it now, right? It's better?
It's still cut off a little bit.
So this is still cut off for you? Mm-hmm. Oh, you could, does the chat cover up part of it?
I have you pinned on the screen so I can see it.
Okay, but it's still like, yeah, it might just be like a distorted thing. So I'll zoom out a little bit like this. Hold on. With this.
If you open chat, I think that goes away. That's what happens. That would happen.
Yeah, that's a lot better. I could see it a lot better.
So wait, what were you saying about the chat also? So I could tell other people?
If you open the chat, at least for me, the cutoff thing goes away.
If you open the chat, like...
Yeah, maybe that's just for me.
Yeah, same, that happens for me.
Yeah, so if you, so you might want to play with the chat closing and opening, see if the settings. I think it depends on if, you know, like when you do like updates with Google and all that stuff. So it might be like what version of Google Chrome you have and blah, blah, blah. But everyone can see at this point, right?
Yeah.
Okay, just making sure. All right, so I see somebody wrote me a little note. Let's see, LT and EB. Yes, 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 yes. Good. So leading terms and end behaviors. So when we're analyzing the end behavior for equation writing, honestly, you kind of don't care about the left side right now. We really care about the right side. Since the right side is pointing this way, what does that tell us about I'm just going to try to focus it more. What does that tell us about the leading term? Good. I see negative. So all we need, I'm going to put a negative. Now, could it be a -1 or a -2 in front? Maybe. But why would you create more work for yourself, right? We just keep it simple, keep moving. So this is an acceptable answer of factored form, right? Now, periods are super short today, so we only have about 2 more minutes. So I'm going to, with period 7, I'm going to change this into expanded form, but I will slightly start talking you through it right now. But either way, it'll be all recorded into one, I'll cut it together, one video. So what I'm going to do is I'm going to rewrite this a little. -x². Then we had x plus 2 cubed. So I would write out for my next step something like that. Okay? and then our 2x minus 3. If you put on your paper this or this, it's fine. They're all acceptable. No big deal. Okay? I'm going to assume that if you did this or this, you may have found it a little bit more annoying to expand. When I expand this with the next period, I think they're already coming in now. Maybe not. Is she in this period? When you do this, you want to make sure you're foiling something like that. Maybe you foil these two, and then you'll have a trinomial times a trinomial, multiply them, and I would save this for the very end as my last thing. From factored form, we want to go into standard form. Some people struggle a little bit with bits and pieces of this. What should we do first? What do you want to do first? Where should we begin? What's something important we should avoid doing? What's something important we should make sure we do? Tell me anything you remember about how we're going to go right now from factored form into standard form by just typing anything you think is going to be important in the chat. How do we get from factored to standard? What place do people make mistakes all the time? What should you do? Oh, Jackson, gold star, Sam, good. So Jackson wrote, good, expand and FOIL, perfect, great. Yes. Jackson wrote to write x plus 2 3 times. Good, because you're going to give me a lot of stress and sadness if you just cube that and that. Okay, we have to remember when you cube something, it times itself 3 times. When it's a sum or a difference, you can't take shortcuts. It's going to mess up the problem. I've gone over examples as to why. So the one example I keep giving is 3 plus 4 squared. If you add 3 and 4, we get 7. And if you square 7, you get 49. But if you just give them both the square, you get 25. So you can't do this. This is lying. Okay? So we write whatever it is more than one time. Okay? So we're going to work on getting that factored into standard. I'm going to do that over here. And like I said, this will all be spliced together into one video. So if you leave a little room on top from where we're picking up, but y equals, I also was stalling, kind of hoping that people were copying and getting a little bit caught up, but we'll see. Now, everyone's going to be a little different in their factored form, and it doesn't mean you're wrong. If you didn't put 2x minus 3, if you messed up and you put 3x minus 2, it happens, right? Or you did like 2x plus 3. It is not the end of the world. If it's like a 10-point question, you might lose 1 point, right? And then you just carry through and finish from there. And as long as you don't randomly get the magical right answer because you looked at someone's paper and you had the wrong setup, well, that wouldn't make sense. But you could have 2x minus 3, or some people might have put x minus 3 over 2, or some people may have put x minus 1.5. Whatever one you use is fine. So let's start off with what Jackson said. So negative x squared, we're going to leave. X plus 2, I'm going to write it 3 times since it's to the third power. And 2x minus 3 is the only factor like that. So we're on our way from factored form to standard form. Now, FOIL, expand, we need to strategize, plan ahead, right? Now, if we're looking negative x to the 2, that'll be x to the 3, to the 4, to the 5, to the 6. So my leading term when I'm done should be, I believe, negative 2x to the 6. So if I get that as my leading term, I know I'm in good shape. What I want to do is I'm going to FOIL the 2 of those together. Now, this is where you might have a preference. If you, let me know which one you like better. Ready? Option 1. I'm going to FOIL that, and I'm going to FOIL that, and I will get 2 trinomials. And then I'm going to multiply the trinomial and the trinomial, and at the end I'll distribute that. That's option 1. Option 2, I will FOIL that. I will get a trinomial. Then I'll multiply it by this. I'll get a new polynomial. And then I'll multiply that by this and get another one. So which one do you guys prefer? And I'll just do it that way. Option 1 or option 2? So again, option 1, I'm going to FOIL that and FOIL that. I'll have 2 trinomials right away. And then I'll take the 3 things here and multiply them by all 3 things here.
That's what I did.
Okay, so does that seem easier to some of you?
That was what's easy to me, but.
Okay, you know what? You're the only one who answered, so we'll do it that way. Thank you. So now, negative x squared, you sit there. I'm going to FOIL this. If you want to type any of the terms that I get from foiling this or this, if you want to type the whole thing, anything you could share in the chat will be immensely appreciated as your participation. I will get x squared, and if you're copying and can't type at the same time, I understand, but jump in whenever you can, okay? X squared plus 4x plus 4. I already combined 2x and 2x. Here, first, I get 2x squared. Outer is negative 3x, and inner is positive 4x. Negative 3 and positive 4 is plus 1x or plus x, and then minus 6. Now, is it possible you mess up one thing somewhere, it mess up the whole problem? Of course. So you want to make sure you take your time and try not to lose your equal sign. Next, I'm always saving this guy for last because people do weird things with this, so save it for the end. Y equals negative x squared. Okay, I'll try to color coordinate as I go to hopefully help people follow along. So I'm going to start with negative x squared, and I'm going to multiply it by all 3 things here, okay? This, and this, and I'll get 1, 2, 3 things over there. Okay, so negative x squared times 2x squared, x squared times 2x squared, I'm going to get 2x to the 4. X squared times x, I'm going to get plus x to the 3rd. And then x squared times negative 6 is minus 6x squared. So that is started. I'm going to continue. I will multiply this, now it's this one's turn, times 1, 2, 3. All 3 things here. And I'm going to get 3 more terms, right? I believe they will line up 1, 2, and 3 over there, if I'm correct. So 4x times 2x squared is plus 8x cubed. 4x times positive x is plus 4x squared. And 4x times negative 6 is minus 24x. Then, last, I'm going to take this term, the plus 4, and I'm going to distribute it to all 3 as well. 1, 2, and 3. And those should line up 1, 2, and 3 over there. So positive 4 times 2x squared, I get plus 8x squared. Plus 4 times x plus x is plus 8x. And then positive 4 and negative 6 is negative 24. Close the parenthesis. So 1, 2, 3, layered them vertically, like doing that, so I can combine like terms straight down in a nice little column. So I'm at y equals, I'll scooch this up a bit, y equals, that negative x squared is still sitting there, combining my like terms. So if you can type in the chat, give me what any one of these terms is, 1, 2, 3, 4, or 5. That would be great. If you can't multitask, do your best. Oops. So we have 2x to the 4 plus.
Miss Thomas?
Yeah.
When you were multiplying the 4 and the x, wouldn't it be 4x instead of 8x?
Oh, good idea. Where is it? 4. Yep. Thank you for catching that. You get a gold star today. You are on the ball. You participated. You caught my mistake. I should start making them on purpose. That was not on purpose. That was just me being silly. Did I make another? Did anyone see a mistake anywhere else? I get distracted sometimes when I'm like looking up and trying to see how you guys, if anyone's asking anything. So I screw up sometimes. 4 times 2 times 1 times -6. It looks okay otherwise, right? Guys, you could also say like answer, so I know I'm not being ignored. You could be like, no, everything else seemed okay to me. Or just put it in the chat. You know, that's how we communicate in life, you know. Adding straight down here. No one told me what they thought it would be, but it's 9x cubed. -6 plus 4 is -2 plus 8 is positive 6x squared. Again, stop me if I make a mistake. -24 plus 4 is -20. And -24 is no one to combine with. And we're almost done. We have one more step. So I'm trying to walk. Oh my God. Talk and write became walk. Talk and write slowly so that you guys have, you know, a good amount of time to get this copied, as well as ask a question or answer a question if you can. But we have one more step to do. What would that last step be?
Multiply -x squared by everything.
Yes. So we're going to distribute that in. That is distribution. That is allowed. That is fine. Normal, run-of-the-mill distribution. Careful, number one place for mistakes in an example like this is we see people start distributing the negative and they write -2x to the 6th. But as they go, they slowly like stop using the negative. Or even more interesting, just don't distribute anymore. They just sort of stop distributing. Okay, so -2x to the 6th. I'll have minus 9x to the 5 minus 6x to the 4 plus 20x to the 3rd and plus 24x squared. Does anyone in here think like, yeah, actually, I may have gotten this one right. So maybe you got this, or another possibility is if you got -1, -4.5, or 9/2, -3, plus 10, and plus 12 instead. So does anyone think like, I may have gotten this one right? Eleanor thinks so. Good. I think that means you think so, right? Not asking a question. Anyone else thinks they did it right?
I mostly got it right. I forgot to add an X after the 20 though.
Oh, over here, like fell off somewhere?
Yeah, so like I forgot to add the X, which meant like I just added I just put the 4x down.
Oh.
A little bit.
Oh, like in this spot, like these got, oh, so it messed up your like end of your equation.
Yeah.
Got it. But if you see how I set it up with the colors, like it kind of helps me know like what column it's going to land in, and you could kind of avoid a little bit those mistakes, but you know, it happens. We're human. What are you going to do? So I'm up to here right now.